So actually we are discussing this reaction mechanisms, how the epoxidations will undergo by using peroxide. So here we can say this is a pi electron cloud. If we have a two lone pair of electron, and this lone pair of electron is not available because it actually involves in the resonance. So it's not available, it's not free. So only the lone pair of electron is available is this. So whenever this oxygen come in contact with the pi electron cloud, what will happen is that the pi electron cloud and lone pair of electrons undergoes repulsions. So undergoes repulsions. Here the pi electron cloud will be slightly shifted towards one of the end. Either it can go here negative, here it is positive. Okay. So once it has become positive, the lone pair of electrons on the oxygen attracted towards to the positive. So we can write like this. So here this lone pair of electron attack here, and the negative charge will attack here. So once the lone pair of electron goes, the oxygen becomes electropositive. It doesn't have an electron donated here. The negative charge attack the same oxygen again. Once it is attacked, this bond breaks up. Okay, so we can write this. So we have an oxygen bond here. So here also there is an H, there is a plus. So here we have minus, double bond, CH3. So this minus needs positive, so therefore it will abstract a proton, neutralize the positive charge. So you will get an epoxide. So this is how the reaction mechanism will work. So we can go ahead by doing problems. So we can take a lot of problems. So here also we have, so we can use so another epoxidizing agent is trifluoroperoxytic acid, trifluoroper 3 oxygen, called as trifluoroperoxytic acid. So we are using only 1 mole. Now we have a 2 bonds, so we need to identify which one is electron rich. So here this is a one end will 2 alkyl groups, this end, other end there is no alkyl group, but here so the 2 olefinic carbon atom have a doubly substituted olefinic carbon atom. So all these electron donating groups, so therefore this is more electron rich. So therefore the epoxidations will undergo above. So here, so it doesn't undergo here. If you use 1 mole, if you use 2 moles, it will undergo both the sides, both the double bonds will undergo epoxidations. So another example, so this is tertiary butyl group, and here we have CH2. We are using metachloroperbenzoic acid, dichloromethane solvent. Now there is a possibility of getting 2 products. So one is major product, another is minor product. So the major product is actually we have hydrogens here. So if the oxygen is inserted in this fashion, in this direction, now that actually created a steric hindrance will be created by this hydrogen, steric hindrance. If it is delivered through in this phase above, there is no steric hindrance, so therefore we will get 2 products. CH2, this is major product, there is no steric hindrance, so we have this. So here we have oxygen, So this is a minor product. This is 69%. This is 31% on the product. So this is there is a possibility of formation of two products. So depending upon the availability or the mode of insertion of the oxygen, that depends upon the steric hindrance. The mentioned product depends upon the steric hindrance. So in order to problems for the solution, so we can take this one. There is a OH group. We have a bonds, a pi bond. In the presence we have OH group, it's an electron donating group. So if the pi bond contains any electron donating group at alpha position, so this is pi bond, this is alpha positions, then the rate of oxidation increases. Why? Because the pi bond gets more amount of the electron, so it becomes more electron rich. So we can carry out the epoxidation. Metachloroperbenzoic acid, dichloromethane, OH. So you will get an epoxidation. So another problem. Now CH3. Here we have CH3. Here we have OH. Metachloroperbenzoic acid. So here the electron donating group, this is weak electron donating group, sigma donation. So this is pi donation. So pi donation is more effective. So look at the stereochemistry of the OH. So it actually below the plane, so therefore it will enhances the electron density below the plane. Electron density increases below the plane. So if it is increases below the plane, oxygen also attacks below the plane only. So therefore you will get, so this is below the plane, oxygen delivers below the plane. So here you will get below the plane epoxidation. So this is CH3 will become above the plane. Compared to this is above the plane OH. So this is the product. So you can predict the product here. The following, predict the product for the following. We have CH3, O2 CH3. This is OH, a double bond. So we are using metachloroperbenzoic acid. So what is the problem? Look at this is the pi electron cloud. So at alpha positions we have OH. This is above the plane. So therefore oxygen also inserted above the plane. So second problem. for benzoic acid. So predict the product for in this case. What will be the product? So next we will start